Random assignment or random placement is an experimental technique for assigning human participants or animal subjects to different groups in an experiment using randomization, such as by a chance procedure or a random number generator. This ensures that each participant or subject has an equal chance of being placed in any group. Random assignment of participants helps to ensure that any differences between and within the groups are not systematic at the outset of the experiment. Thus, any differences between groups recorded at the end of the experiment can be more confidently attributed to the experimental procedures or treatment. Random assignment, blinding, and controlling are key aspects of the design of experiments, because they help ensure that the results are not spurious or deceptive via confounding. This is why randomized controlled trials are vital in clinical research, especially ones that can be double-blinded and placebo-controlled. Mathematically, there are distinctions between randomization, pseudo-randomization, and quasi-randomization, as well as between random number generators and pseudo-random number generators. How much these differences matter in experiments is a matter of trial design and statistical rigor, which affect evidence grading. Studies done without randomization include quasi-experiments and open-label trials. Those done with pseudo or quasi-randomization are usually given nearly the same weight as those with true randomization, but are viewed with a bit more caution. Benefits of random assignment. Imagine an experiment in which the participants are not randomly assigned. Perhaps the first 10 people to arrive are assigned to the experimental group, and the last 10 people to arrive are assigned to the control group. At the end of the experimenter finds differences between the experimental group and the control group, and claims these differences are a result of the experimental procedure. However, they also may be due to some other pre-existing attribute of the participants, e.g., people who arrive early versus people who arrive late. Imagine the experimenter instead uses a coin flip to randomly assign participants. If the coin lands heads up, the participant is assigned to the experimental group. If the coin lands tails up, the participant is assigned to the control group. At the end of the experimenter finds differences between the experimental group and the control group. Because each participant had an equal chance of being placed in any group, it is unlikely the differences could be attributable to some other pre-existing attribute of the participant, e.g., those who arrived on time versus late. Potential issues. Random assignment does not guarantee that the groups are matched or equivalent. The groups may still differ on some pre-existing attribute due to chance. The use of random assignment cannot eliminate this possibility, but it greatly reduces it. To express this same idea statistically, if a randomly assigned group is compared to the mean, it may be discovered that they differ, even though they were assigned from the same group. If a test of statistical significance is applied to randomly assigned groups to test the difference between sample means against the null hypothesis, that they are equal to the same population mean, given the probability distribution, the null hypothesis will sometimes be rejected, that is, deemed not plausible. That is, the groups will be sufficiently different on the variable tested to conclude statistically that they did not come from the same population, even though, procedurally, they were assigned from the same total group. For example, using random assignment may create an assignment to groups that has 20 blue-eyed people and 5 brown-eyed people in one group. This is a rare event under random assignment, but it could happen, and when it does it might add some doubt to the causal agent in the experimental hypothesis. Random sampling. Random sampling is a related, but distinct process. Random sampling refers to recruiting participants in a way that they represent a larger population. Because most basic statistical tests require the hypothesis of an independent randomly sampled population, Random assignment is the desired assignment method because it provides control for all attributes of the members of the samples, in contrast to matching on only one or more variables, and provides the mathematical basis for estimating the likelihood of group equivalence for characteristics one is interested in, both for pre-treatment checks on equivalence and the evaluation of post-treatment results using inferential statistics. More advanced statistical modeling can be used to adapt the inference to the sampling method. History. Randomization was emphasized in the theory of statistical inference by Charles S. Peirce in Illustrations of the Logic of Science, and A Theory of Probable Inference. Peirce applied randomization in the Peirce-Jastrow experiment on weight perception. Charles S. Peirce randomly assigned volunteers to a blinded, repeated measures designed to evaluate their ability to discriminate weights. Peirce's experiment inspired other researchers in psychology and education, which developed a research tradition of randomized experiments in laboratories and specialized textbooks in the 1800s. Jersey Neyman advocated randomization in survey sampling, and in experiments. Ronald A. Fisher advocated randomization in his book on experimental design. Links. Experimental Random Assignment Tool.